Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 4B. Myself, Priyanshi Goyal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 10th World Conference on Information Communication Systems, Software, Security, and Sustainability, WorldS4 2026, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom from 29th to 30th of July 2026. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. I request everyone to kindly adhere to the designated time. I also request the participants to check their network so that there are no challenges in between the session and to turn on your cameras while you're presenting. Please make sure your mics are turned off when other participants are sharing their work. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Anubha Jain. Just a second. Is my
Hello,
screen visible?
Priyanshi.
Hello, ma'am. Is my screen visible?
Yeah, now it is.
All right. Dr. Anubha Jain is an associate professor and director, School of Computer Science, and IIT IIS, deemed to be University Jaipur. An academician for the last 23 years, she has actively contributed in teaching, industry, and R&D. Her research interests include soft computing, computational studies, IoT, data analysis, deep learning, algorithms, and data structures. She is the author of 9 books and has published a number of papers at national as well as international levels. Thank you so much, ma'am, for joining us today. Before commencing this session, I request you to share a few words of encouragement for our
Yeah,
participants.
thank you, everybody. A warm morning to everybody. And I wish all the participants all the best for their presentation. So, every research is a good research. And whatever work you are doing, keep on doing it. It's always for the betterment of the society. Thank you very much.
Thank you so much, ma'am. Thank you for your kind words of encouragement. So, without delay, let's start with the first presentation for the session. I would like to request Sir Osama Hamid to kindly present his paper titled A Threat Model Driven Architectural Framework for Motion Based Facial Authentication in Secure Web Systems. Do we have you here with us, sir? Is anyone else from the team present? All right, since there's no response, we'll be moving forward. Kindly note that any presentations that are missed will be taken forward at the end of the session. I would now like to request Sir Raed Daud to kindly present his paper titled Artificial Intelligence and Robotics for Warehouse Automation, a systematic review of design and performance. Do we have you here with us, sir?
Hello, he's not available, so I will be telling
All right.
the yes.
Please introduce yourself and please share your work.
Okay. Let me share the screen first.
Sure.
Okay. Good morning, and thank you for the chair and to the organizer for this opportunity. My name is Ziad Sabah Hussein, and I'm from Northern Technical University in Iraq. And today I would like to present our review paper, Artificial Intelligence and Robotic for warehouse automation, a systematic review of design and performance. It's a joint work with Dr. Raid Daoud, Ihab Satam, and Mohammed Fakhruddin. The question behind this work, it's simple one. In a it's simple one. In a warehouse robot fleet, where should the computing happen? On every robot or on one central server? Just let me change the slide. Okay. First, why this matter now? E-commerce keep growing. There are more orders and less time to deliver them. At the same time, it's harder to find workers for repetitive and heavy tasks. Orders have also changed. Patches are smaller and product change much more often. And all of this must happen without increasing the cost per unit. The industry answered this with a mobile robot, automated guided vehicles, and autonomous mobile robot. They are now the main technology in warehouse logistics. But reviewed paper agreed on one point: adoption is still limited, and the limit it's not what the robot can do. The limit is the cost and the complexity. Let us look at how these robots are built today. First, automated guided vehicles follow fixed guidance, wire, magnet, or tape on the floor. They are simple and reliable, but they cannot move sideways. So in narrow aisles, they need servo movement to turn and dock. Autonomous mobile robot have LiDAR, SLAM, and often deep learning on every single unit. This works, but it makes each robot expensive and limited on how many robots you can operate. Both designs are usually decentralized. Each robot carry its own map, its own sensor, and make its own decision. So every robot you add repeat the same expensive hardware. The cost grows together with the fleet. That's the gap we addresses. A robot that move well in tight aisles and carry heavy loads without paying full sensing and computing on every robot. Our review covers three areas. First, the mobility, the differential drive platforms compared with omnidirectional bases. Second, localization and perception, heavy SLAM and LiDAR compared with light methods such as floor markers and barcodes. And the third, the most important one, where the computing sit, decentralized on the robot or centralized on the server. We compared the report result using 5 measurements: throughput, accuracy, scalability, and cost, and energy. About related works, there's 5 representative studies from the review. Iman Wilson and colleagues used a multi-agent rollout method for path planning and reduced deadlocks and collision in dense warehouse. Escobar Naranjo and colleagues used deep Q network for trajectory optimization and got better obstacle avoidance than classical control. Konishi and colleagues combined deep reinforcement learning with supervisory control theory. This is an interesting because they kept the efficiency of learning and still provided a safety guarantee. Now, please look at the last column where computing set. In almost every study, the intelligence is added to the robot only if you works moved it to central level. This is exactly why the costs grow with the flat. And it's the assumption we want to question. Let me move to the next slide. Okay. So let us compare the two options directly. On the left, the decentralized approach where each robot decides on the right, while on the right, the centralized approach where one server decide. First, the map. In decentralized design, every robot builds its own map with SLAM, while in the centralized design, there's one global map and it lives on the server. Next, planning. I'm sorry. In decentralized design, each robot plans only for itself, so robots may end up blocking each other. In centralized design, the central server plans for the whole fleet at the same time. Then the sensors, the decentralized design needs LiDAR, camera, and computer on every robot, while the centralized design need only markers, barcode scanner, wheel encoder, and an IMU. This leads to the cost in the first case. The expensive hardware is repeated on every unit. In the second case, it's bought once and shared by the whole fleet. And the last row, it's the key one. When you add more robot in decentralized design, you add complete sensing and computing stack. In the centralized design, you add a chassis and Wi-Fi link only. So our position, it's the one at the bottom of the slide. Keep the robot simple and move the intelligence to one place. This is the architecture we propose shown in figure 1. In the center is the central warehouse server. It holds 4 things, the global map, the product database, the path the path planning model, and the fleet management engine. Around it, simple robot client. Each one has mechanism wheel chassis, so it can move in any direction, a lift mechanism plate, and a barcode or QR scanner, a Wi-Fi link, and a small controller for motion and controlling the robot. There's no LiDAR, no SLAM on the robot. Everything that's expensive to compute has been moved to the server. I will explain how one order is executed. First, the order arrives at the server, then the server finds where the item is located. Then the server computes the best path and chooses the next free robot and send very simple command like go to that position or follow this path. Afterward, the robot executes the motion with the mechanism wheels and tracks its position using wheel encoder and IMU, and the server corrects the position each time the robot scans the floor markers. The robot arrives and scans the barcode to confirm the correct item and lifts it up. At the end, after delivering the product to its destination, the robot reported back, so the server update the inventory and the robot position and occupies the path. Then sends the next task to, if there's any task, it sends it to the next robot. If you notice the division of this work, the server thinks and the robot only execute. What the fleet gains. So does centralizing actually give us the well, yes, the robot becomes simpler because the mapping, planning, and coordination leave the robot completely. The unit cost falls, and because the expensive part it's bought once instead of per robot, and the fleet can be much larger because one more robot adds only chassis, not another computer. Cloud-based control shows that robot sharing one global map can be optimized as a whole fleet rather than one by one. And fleet management research names task sharing, communication, and global coordination as a hard problem in multi-robot system. A single server engine can handle all 3. I would like to be honest about the cost of this choice. A central design depends on the server, on the network. That's the real trade-off. We might have single point of failure, and in deployment, it has to be handled with a backup server and with local behavior, safe local behavior on the robot. About the mobility, the next slide explain how we keep the robot simple but still capable. Let us start with wheels. Differential drive cannot move sideways, so to duck at a shelf, it must turn, move, and turn again. While a machinum wheelbase, by contrast, has three controllable degree of freedom. It can move forward, sideways, and rotate at point, and each one it's independent. Comparative studies show that these platforms have much larger set of possible movement, even with real limit on wheel speed and
This is a
experiment.
gentle reminder.
Excuse me,
Kindly
what?
conclude in 2 minutes.
Okay. Experiment shows this platform has much larger set of possible movement, even a real limit on wheel speed. An experiment for wheel machinum wheel can confirm accurate motion and obstacle avoidance in clutter indoor space. For warehouse, this means faster side docking and precise position in front of the rack. Our focus here is space, not speed. And this is why we choose machinum wheel. Now I want to return to artificial intelligent part of this title because this is where the central design gives the biggest advantage. AI in warehouse is expensive mainly for one reason. In decentralized fleet, every robot need a GPU or an AI accelerator to run the model. In central system, you need only one model running on the server. The robot need no AI hardware at all, so the cost of intelligence doesn't grow when the fleet grows. The second advantage is the data. Every robot sends its scans and telemetry to the same place, so the model learns from the whole fleet instead of one robot only. And the third is maintenance. When you improve the model, you update it once on the server. You don't update software on every robot individually in the building. On the right, you can see where AI actually acts in our architecture. We use it for task allocation, deciding which which robot takes which order, fleet level planning, demand prediction from product database, predictive maintenance for the fleet telemetry, and vision on the server for verifying markers and products. So the message is this: centralizing does not take AI out of warehouse; it puts AI warehouse where warehouse
You
can
have
actually afford it.
you have crossed the 12-minute mark. I request you to kindly conclude the presentation.
Okay. Let me just show the. Can I finish the conclusion if there's any
Yeah,
time left?
just finish the conclusion. Just finish the conclusion.
Okay, I'm sorry for taking so long. Um, To conclude, our argument is that warehouse flat scales when the computing is centralized, not when each robot made more intelligent. The server keeps the global map, the path planning, the flat coordinate, and the AI model. That's where the cost and the complexity belong. And it's also what makes artificial intelligence affordable at the flat scale. The robot stays simple, machinum wheel for tight space, and lift mechanism for plate, and cheap perception with markers and barcode. I'm sorry for taking so long, and if you guys have any question, I'm happy to answer them.
Thank you so much for such a good presentation, sir. Are there any questions?
Yeah. Am I audible, Mr.
Yes, ma'am.
Hussain? Yeah. So it was very well presented. You tell me, are you people taking this work in the future for developing something or implementing this suggestions that you have given?
Well, yes, we are actually currently working on building such a robot that's purely centralized and doesn't have any competition or processing in the server in the robot itself.
So the diagram that you had shown, that was a part of your study or that was a resultant of the review?
It's part of my study.
The direction one.
Let me this one. I don't know if the screen is sharing.
Omnidirectional and differential direction wheels diagram that you had given comparative analysis.
Mobility and
Yes.
manipulation, right?
So this is the
Okay.
diagram of the robot that you are developing, right?
Well, yes, we are working on building a robot with omnidirectional wheels, mechanism wheels, exactly.
Okay, and what are the challenges that are being faced in doing that?
Well, the challenge is it's a mechanism wheel. It's very sensitive for slipping and doesn't work on an even floor. But since the robot it's built for storage system warehouses, I don't think there will be such a scenario where the floor is not even or such a case.
Okay. Okay, thank you.
You're welcome.
Thank you, sir. Can you please stop present?
Okay.
Yeah, all right. No worries.
Thank you. Thank you so much.
Thank you. Moving forward, I would like to request Ma'am Glizina Renul to kindly present her paper titled Mitigating Strategic Misalignment and Data Configuration Problems through COVID 2019, an IT governance strategy for public sector firms. Do we have you here with us, ma'am?
Yes, I'm Gulsna Rinarmulan from Gamulia University.
Ma'am, you're not clearly audible.
Okay, thank you.
Yeah, okay. Yes, you can start presenting now.
Okay, can you see my presentation?
Yes, your screen is visible. Can you please put it in presentation
Okay.
mode? Yes. All right, you may
Okay,
start.
thank you. Thank you. Good morning, everyone. I want to present our research entitled Mitigating Strategic Misalignment and Data Configuration Problems Through COVID 2019, an IT governance strategy for public sector firms. The authors is Johannes Fernandes Andri, Hendy Tanadi, me, Luisina Rembulan, Onke Alexander, and Aguana. And the introduction is rapid digital transformation force public sector organization to govern IT strategically for alignment with organizational goals. The problem is most organizations still face critical challenge. Lack of alignment between business and IT, unavailable configuration data management affecting maintenance, incident handling, and service delivery. And then human factors, including user resistance, inadequate training, and lack of user involvement. And the research gap is prior IT governance. Research heavily focuses on compliance and controls, often neglecting strategic integration and configuration data validation challenges. And objective is the study proposes an all-encompassing IT governance model using COVID 2019 framework to address technical, strategic, and human pillars within a public sector case study. And the methodology is a qualitative case study methodology, three core phases. The first is evaluating the current state of affairs regarding IT governance and determining gaps and problems areas and creating an IT governance strategy. And research framework COVID 2019 is core design factors or DF experiment. The framework introduces the F1 until the F5 to determine priorities, and study ultimately evaluates all 10 design factors, the F1 until the F10. Key COVID demands included EDM, evaluate, direct and monitor, and APO, align, plan on, and organize. And data collections is triangulations, interviews, semi-structured sessions with management, project managers, and IT specialists, document review, evaluation of organizational SOPs, system doc, and governance policies. And observation is direct observation of software development, deployment, and monitoring processes. COVID 2019 Toolkit is questionnaires based on the framework to assess baseline capability levels. And data analysis is current state, benchmarking capability scores using COVID 2019 design factors. And second is gap analysis, identifying operational deltas between current and desired governance states. And risk mapping, plotting identified issues into impact and likelihood risk grids. And then thematic analysis, extracting qualitative terms from interviews and observation logs. And the result is analysis 10 design factors, the F10 until the F1 until the F10. Governance is generally stable, but a strategic alignment gap reduces IT governance effectiveness. And the first is evaluation of enterprise strategy, or the F1. All four dimensions, growth, innovation, cost leadership, client service, score a baseline 3.0. This balanced approach risks a lack of prioritization, potentially hampering COVID's goal cascade process. And the second is an enterprise goals analysis, the F2. All goals score below 3.0, showing low prioritization. This severe strategic misalignment negatively impacts IT investment, value realization, and resource utilization. And a third is risk profile assessment, or the F3. Average score is 2.5. Moderate risk performs well in APO 12, manage risk, and APO 13, manage security, but human resource constraints pose long-term risks. And the fourth is IT, related issues and compliance, or the F4, high regulatory maturity with a compliance score of 3.0. However, compliance is operational, creating an inconsistency with the strategy in the F2. And the next is perspective and integrated and compliance. Defensive philosophy prioritizing data protection over strategic expansions, and the implication is overemphasizing risk prevention hampers innovation and lowers value creation. And the sixth is importance of threat landscapes. Threat landscape is 60% high and 40% normal. Proactive risk management reinforce target scores, or positive 0.8 for EDM 03, risk optimization, APO 12, and APO 13. And the F6 is significance of compliance requirements. Compliance is 50% normal, 30% low, and 20% high. It treats as an operational function rather than strategic, with a notable exception in the SS05 Managed Security Service plus 0.20. And the F7 is a role of IT in the organization, or importance of role of IT. Multidimensional roles, support, victory, strategic turnaround. Average score sits below benchmark 18.35 versus 19.91. But operational support, the SSO3 until the SSO5 remains crucial. And then the F8, importance of IT resourcing strategy, heavily outsourcing 50%, cloud 40%, insourcing 10%. This flexible model optimizes performance but heavily increases dependency on APO 09 service relationship and APO 10 vendor management. And the F9 is importance of IT implementation approach. Equal development mix, DevOps 40%, waterfall 40%, agile 20%. Optimizes flexibility and process control, showing peak improvement in BAI03, manage solution identification and growth. And the last is the F10, technology adoption strategy importance, blends innovation, first mover 45%, follower 35%, slow 25% positively impacts effectiveness, yielding notable gain in APO02 managed strategy and BAIO1 managed programs. And the discussion is current performance status and critical areas requiring improvement. Current performance status is sufficient performance in risk and security management, especially within APO 12 risk management and APO 13 security management. For operational issue, the organization treats related goals as an ordinary operational process rather than a strategic priority. And then the critical areas requiring improvement is data security and protections. Customer-oriented service culture, and then strategic alignment. And then another discussion is actionable governance solutions, strengthening risk and security governance, implement highly effective security policies paired with continuous monitoring strategies, raising compliance to strategic level, embed regulatory compliance factors directly into the core corporate strategic decision-making process. And then improving IT capability and skills development, conduct targeted training sessions and capability development programs. And then improving customer-oriented service orientations, systematically align deployed IT services with customer experience objective. And the last is improving strategic alignment mechanisms, elevate the practical role and utilization of the COVID 2019 goal cascading process. And the conclusion is research baseline, COVID 2019, the F1 until the F10 successfully benchmark public sector governance across strategic, operational, and technological dimensions. And the key strengths is high maturity in risk management, compliance, and service continuity, proving a stable, control-based governance systems. And the core weaknesses is serious corporate IT misalignment due to unprioritized enterprise objectives, insufficient configuration data management, hindering real-time decisions and incident response, human barriers, including change resistant and low IT competence. The verdict is the organization's risk-based IT governance model favors operational stability over innovation and value creation. And the last is proposed IT governance models integrates COBIT's goals cascade, automated data validation, and proactive change management.
Okay, I have a question to you.
Okay.
Yeah. Just tell me that how do these COVID 2000 design factors and management of objectives bridge the gap between public sector policy goals and technical database configurations to prevent strategic misalignment?
Okay, I will beginning from the aims of the study. The study aims to evaluate the organization's current IT governance conditions, identify strategic, technical, and human-related gaps, and develop an IT governance strategy using COVID 2019. And then, the second question is about the strategic misalignment axis. Okay, the main evidence is the contrast between the F1 until the F2. The F1 solves that all four enterprise strategy dimensions scored 3.0, suggesting is a balanced but unprioritized strategy. And the F2 solves that all enterprise goals scored below the baseline of 3.0. This mismatch weaken the COVID goals cascade indicates the enterprise priorities are not effectively translated into IT government priorities. That's it, Miss.
Ma'am Anuva, are you still there?
Yeah, thank you. Over to the next
Okay.
speaker. And there's a request that
Okay.
please stick to the time, all of you.
Okay, thank you.
Yeah.
Thank you so much, ma'am.
Thank you.
Moving forward, I would like to request Ma'am Shin Ju to kindly present her paper titled Multi-Scale Attention and Multi-Channel Fusion Network for Image Derailing in Complex Scenes. Do we have you here with us, ma'am?
Yes, I am.
Just a second. You can start sharing your screen.
Okay, I will show my screen.
Sorry, you're not clearly audible. Hello?
Did you hear me?
Yes, like your voice is very low. Can you just like increase the volume also? Keep the mic near you.
Now I'm beginning my show. Good morning, afternoon, everyone. My name is Xinyi Zhu from Hubei University of Technology. Today, I will present our work entitled a multi-scale attention and multi-channel fusion network for single image derailing. I will introduce the main idea of the network and the result. First, let us look at the background.
Your voice is not audible. Zenil, your voice is not audible. Can you be a little louder?
Maybe I try. Could you hear it clear?
Yes, it's a bit better.
Let me begin. Let us look at the background. Rain can reduce the quality of the outdoor image. It may cover important object blue image edges and remove the texture detail. This problem may also affect computer vision tasks, such as object detection and image recognition. A single image derailing aims to recover a clear image from one random image. However, this task is difficult because only one input image is available. There are three main challenges. The first change is that rain streets have difficult size. Some are thin and short, while others form large rain areas. The second challenge is that rain is not evenly distributed in an image. The third challenge is that different feature channels contain different information, such as rain, edge, and texture. This feature need better selection and fusion. To solve these problems, we designed the flow method. Our method has three main parts. First, the multi-scale model extrudes the rain feature and the different scales. Second, the attention model selects useful channel and the important image regions. Third, the multi-channels model combines information from different channel groups. Together, this model improves rain removal and background preservation. Next, I will introduce the whole network. The slide shows the over network. First, the rain image presents a shallow feature extrude layer. Next, the multi-scale model extrudes the rain and the background feature and the different scales. The attention model then strengthens useful feature. After that, the multi-channel model exchanges and combines information from different channel groups. Finally, the reconstruction layer produces the clear image. The whole process includes feature extraction, feature selection, and feature fusion. Now, let us look at the first model. The first model uses three parallel branches. The first branch uses the 3 by 3 convolution to capture then rain streets and the local details. The second branch uses a dilated convolution with a rate of 2 for middle-scale RAN. The third branch used a rate of 3 for larger RAN area and wider background information. The three outputs are joined and fused by a one-by-one convolution. This helps the network process RAN at different scales. The extruded features are then sent to the attention model. The attention model contains channel attention and the spatial attention. Channel attention give different weights to different features channel. Spatial attention focus on important image regions, such as the RAN area and the object edge. The attention weights are produced from the input feature, so they are not fixed. This helps the network keep useful information and reduce less useful information. Next, this feature enter the multi-channel model. First, the feature is divided into several channel groups. Different groups may contain RAN, texture, or edge information. The model allows this group to exchange information. A one-by-one convolution is then used to fuse the feature. We also use the reciters connection to keep the orange useful information. Finally, the two parts are added together to produce the out feature. Next, I will briefly introduce the loss function. We use two loss functions. The L1 loss reduces the picture difference between the output image and the ground truth image. The SSIM loss helps preserve image structure. The final loss combines these two parts. Except the model remove RAN while keep edge and the texture. Now let us look at the experiments. We trained the model on RAN 40,000. We test it on RAN 100H, RAN 100L, RAN 12, and the SPA dates. This dataset include heavy RAN, light RAN, different scenes, and the really RAN image. We use PSNR and the SSIM as the evaluation metrics. We compare our model with the four existing methods and the base network. First, let us look at the results. Our method performed well on the four datasets. On RAN 100H, our PSNR is slightly lower than Ristoma and the IR-SDE, but our SSIM is higher. This shows better image structure preservation on RAN 100L. Our method reaches 38.74 dB and 0.9812 on the real-sparse database. Our method achieved the best result in the table with 29.86 dB and 0.931. We also compare our model directly with the base. Compared with the base, our method improved PSNR on all four datasets. The largest gain is 1.12 dB on RAN 100L. SSIM also improved on every dataset. These results show that the proposed models are useful for heavy RAN, light RAN, CCL image, and the real RAN image. Next, let us look at the visual result. This slide shows the visual compression. Some other methods still leave RAN strips or lose small background detail. Our method remove more visual RAN while keeping clear edges and texture. The result also look more natural in heavy RAN and the real image example. We also test the FSO for each model. We add three models to base step by step. After adding the multi-scale models, the result improved on all three datasets. The attention model brings future improvements. Finally, adding the multi-channel model gives the best result. Compared with space, the full model improves both PSNR and SSIM. This parameter num is only increased from 0.69 minutes to 0.81 minutes, so the actual model cost is small. Finally, I will give a short conclusion. In conclusion, we propose a network using multi-scale extraction, attention, optimization, and multi-channel fusion. The three models help the model process different RAM patterns, select useful feature, and compare channel information. Experiments showed stable improvement on both really RAM image. In future work, we will study extremely heavy rain and complex light condition. That's all. Thank you for your attention.
Yeah, thank you, Zunail. Yeah, it was a very good presentation. In fact, the images that you have used that gave the proof that you have really done a good work. Congratulations on that. Firstly, how long did it take you to complete this research? Am I? Yeah.
Maybe 3 months.
Okay. Tell me which technique you use to preserve edges and textures.
Do you mean the 3 parts?
Yeah, basically the technique.
Sorry, I may not fully understand the question. Based
Yeah.
on our current words, I can explain the main idea of our method. Our method has three main parts. The multi-scale model extracts range feature at different scales. The attention model selects useful feature. The multi-channel model combines different channel information. Our experiments show that three models improve both PSNR and the SSIM.
Okay, thank you.
Thank you, ma'am, Shaniju.
Thank you.
Moving forward, I request Sir Jatmiko Yogopriyatno to kindly present his paper titled Smart Mura, a practical approach to resolving ambiguity in public decision making through participatory system design. Do we have you here with us, sir?
Okay, thank you.
Yeah. Just a second. You can share your screen now.
Yes.
Is there any issue with sharing the screen?
You share.
Yes, your screen is visible. You may start.
Think you are muted, sir. Kindly unmute yourself.
Sir Jatmiko, you're not audible. You are on mute.
Is he being able to hear us?
No, he is on mute mode.
Yeah,
Kindly
he's
put them
on
in
mute,
unmute.
but he's not getting what you are saying, I think. Can you
Just a
unmute
sec.
him, Priyanshi?
I can't unmute him, ma'am. I can just yes.
Okay. So I'm
Yes,
sorry.
you're audible. You can
Yeah.
start again. We missed everything that you started with. Oh, your screen sharing has stopped. Please share your screen again and then we can start. Yes, your screen is visible.
Okay, thank you. Good morning, good afternoon, and good evening, everybody. Assalamualaikum warahmatullahi wabarakatuh. My name is Jatmiko Yogo Priyatno with our partner Nur Shanti and Yori Hardayani. Our research title is Smart Mura, Practical Approach to Resolving Ambiguity in Public Decision Making to Participatory System. Desain saing riset, analysis of integrity aspirasi, and minute management information system development by DPRD Musirawas in Indonesia. The presentation roadmap is the problem case study, mechanism 1, mechanism 2, mechanism 3, and mechanism 4. Ambiguitas is structural problem, not inconsistent. In Musirawas, too much standardization, right contact, and potential injuries. Bounded discretion TDSS zone to too much discretion for ability of operation and inconsistency. Decision ambiguity, understand service quality, institution trust, and democratic accountability. Public administration has long framed the response as a binary choice, and both extreme carry real governmental costs. For question study, reset question 1, what mechanism does Smart Mura employ to reduce procedural authority and systemic ambiguity? Reset question 2, how does the system achieve a productive balance between standardization and flexibility? Reset question 3, what government benefit does ambiguity resolution produce for citizen of an official? And the last reset question, what generalizable design principle can be derived for replica as well? This is a smart Mura participatory digital government system, integrated aspiration and minute management information to develop for step. First, development by DPRD Kabupaten Musyawas Sumatera, manage citizen aspiration, correspondency and minutes, target chronic procedural authority and substantive ambiguity, and the last document in user guide read to stakeholder social contract. 5 organization level tepat sustainable focus discuss to negotiate rather the boundary between automation and discretion. This is a 5 stakeholder level in table: legislative leadership, council members, secretaries and structural office, and frontline apparatus, and the last IT staff. Design reset, first step, fitur identifikasi every role and technical function in the system. Step 2, ambiguity mapping. Step 3, mechanism extraction and benefit analysis. Design science reset DSR to design an epistemology for generating participative knowledge about system design, problem identification, objective definition design, and development demonstration evaluation communication. Primary data shorts the smart Nora user guide, read social contract according stakeholder agreement, triangulasi talk in internal consideration, logical and stakeholder confirmation. Finding 3 mechanism resolve and 3 ambiguity. First one, bounded automation. First two, explicit judgment point and flexibility categorization. Bounded automation for procedural standard is the schedule notification to the send by WhatsApp to 5 for fixed interval, 7 day, 3 day, 1 day, and 2 hour. Rule-based access control act definition rule the institution authority structure mechanism readable and envelope and the intelligence. Automatic unique identification is every item receives a percent unanimous reference that survive from the closure. Mechanism 2, expressing judgment point for authority disambiguity, rather that heeding discretion that the system makes. That point is the case life cycle and describable discretion, each bound to name, role, and immutability. This is a case cycle 3 name point of accountability. Mechanism, the last mechanism, flexibility category and structure responsiveness to substantive ambiguity is resolved by pairing frame classification set with deliberating from it cannot anticipate. Structure, three-dimensi taxonomy, source, type, and priority, and responsive with escape value to multi-tagging and free text contact file. Structure pluralism is consistent through taxonomy, responsive to escape values, not a false choice between right category and the free for all. Impact finding for interdependent government benefits. The benefit reinforce one other central law, the cost of engagement, considering the trends enable learning and efficiency sustain all three. For citizen, a single portal and descriptive time allow to cost civil engineering for every citizen, not only to well connect. For fairness, is a treatment consistency, a structural similarity case, and handle to same way, recording both the reality and perception of favoritism. For oversight, traceable accountability, complete design and audit train make system perform monitoring and institutional learning possible. For official operational efficiency, cognitive load falls over stop resolve the same procedural uncertainty case of after case. The transparent creation structural framework is TDSS, transparency, discretion, spatial structure. First one, the center bounded automation. First two, explicit judgment. Three, flexible categorization, and the last, participatory foundation. For design principle, move e-government design beyond the binary of standardization versus discretion. The question is no longer how much discretion, but how discretion spreads in structure, owner, and made visible. For recommendation policy maker, first one, to invest participatory deliberation, make a presentation transparent and resist over automation, and the last, document the rationale. Limitation study documentary, not observation. The analysis rest is design document and FDG process, not rather that sustain file observation of day-to-day single case design, a priority for the theory generation in DSR, but constraint what we can claim about generalization.
This is a gentle 2 minutes reminder.
Okay. Uh, Conclusion, the decision ambiguity can be resolved structurally, not choice between standardization and discussion, but making discussion space transparent, bounded, and participation. Thank you.
Okay, so definitely participatory approach is very good in public decision making. So, how will you be able to address a large group of people? Will this framework be able to scale itself in case of diverse inputs?
Okay, thank you.
Am I audible to you?
Yes, ma'am, you're audible. Sir, ma'am is asking a question. Ma'am, can you repeat?
Yeah. Is this framework scalable?
Sir, are you still there?
He's there, I think. Are you being able to hear me, Jatmiko? No, I think let's move to next participant then.
All right, ma'am. Thank you, sir. Moving forward, I would like to request Ma'am Aruna Kumari to kindly present a paper titled Transforming Vegetable Waste, a Digital Solution for Sustainable Food. Do we have you here with us, ma'am?
Yes, I am available.
All right, ma'am. Can you please share your screen?
Are you able to see my screen, right?
Yes, ma'am. Your screen is visible. Can you please put it in presentation mode? Yes, ma'am. You
Kindly
may
let me
start.
know you are able to see. Yeah. My title is Transforming Vegetable Waste into Digital Solution for Sustainability. Mainly, it focuses on for the society. Here, why I'm calling is society. Here, three E's will be plays major role because this is economically and environmentally. What kind of economically? When you're buying something like food or whatever it may be vegetables, it will be wasting means whenever you are getting out, throwing outside or it will be fell down and some rain will be happen, so it will be accumulated the bacteria kind of thing. So that e also we need to eliminate for this proposed work, and then environmentally we can save this into environmentally with the precious thing into this, so this completely work will be helpful for the society. So this is the contents of my work. Then how the global food wastage will be happen, day-to-day evaluation, almost 1.3 billion food will be approximately waste in the yearly basis. Though how the food stuff will be consumer when we consumes and what is my main motive and how the model will be available. First, I need to pre-train, then after predict. So pre-train for we can utilize the mobile net V2 for detection and for these prediction, we need to use YOLO V8 version. So here, the globally wastage of food, one third in the yearly. So 1.3 billion food we are wasting here. So the prediction model. So there are two things here we need to predict when you are giving the some vegetable. It will be predict like fresh, then you can utilize for the zero wastage of your cooking of food. Then it will be predicted some routine, then you can use the compost. This is the main motive tagline for the my research. So first you need to detect and then classify the freshness of the vegetable or fruit, whatever it may be. Then you need to utilize MobileNet V2. So MobileNet V2 is the lightweight CNN. So first you need to extend your picture or image you need to utilize this. This will be supposed to one by one. Then you need to resize and those stuff into like image clarity. You need to expand. You need expand image. You need to utilize for the expansible. You need to resize at the small. You need to utilize this. So mobile V2 net V2 is the more useful for the image clarity. Then to find out the type of vegetable, first you need to upload whatever the vegetable, carrot, tomato, whatever the vegetable you have, you need to upload. That is the web-based. We need to design in the front end. For the back end, so we can use the SQL database. So first you need to take the screenshot for the web-based class, then upload your image. Then it will be give what vegetable type and where the condition will be, which we have the two conditions. One is the fresh and then the routine. For the fresh, we have the zero waste recipes. For the spoiled one, we need to use the compost. Then recommended zero waste for the recipes for the fresh vegetable and recommended suitable compost for the process of the routine vegetable to inform the consumers and encourage the sustainable dieting. Here is the introduction. So I told like two E's, right? Economically and environmentally.
You can skip the
Then,
introduction, Aruna.
sorry?
Let's just skip the introduction because you've already given the introduction.
Yes. Okay then. Okay. So then we need to aware of this. Then emitting of wastage. Then it's a serious cause of environment. So emitting of 11.8 percentage. So then I'm moving to proposed system. So this is my proposed architecture work. First data collection, then pre-processing your web scraping, then upload your image. It will be give the pre-processing techniques. So here we are the data augment also plays the major role because of we need to zoom in, zoom out, and we need to label the vegetable type. Then we can use this data augmented rotation for the all the conditions of data. We need to insert the image. That will be helpful. Then mobile V2 for the CNN, the prediction will be happen. Then the classification with the fresh or the routine. Then recommendations will be helpful for the routine or the fresh of these. Experimental results here, we have the train phase and test phase. Here we have the train for the blue line indicates that the huge data we need to insert it into the train and we can validate this. For example, we take it as 100% of photos we need to upload. It will be divisible by like 40, 60 or 10 of validation phase. We have extend y-axis. The blue line indicates that the good precision for the 1.0. The gray lines is the number of vegetables we uploaded, and it will be give the how the things will be happens according to our work. The final conclusion, when it will be need to sustainable with module like pulling into information like here we give some recommendations in spontaneously that will be not happen as of now. So we like only detection will be happen, then future work we can accumulate automatically generated with this will be possibility for the given vegetable and fruit that will be happen for the next like further. Thanks for this giving opportunity. If you have any queries, kindly let me.
Aruna, it's a good topic for research. Are you doing PhD on it or it's a small research project?
No, I'm already done my PhD. Actually,
Okay, great.
this is memorable for my conference because my first research paper is published in this conference itself, like first international.
Okay. So I have a question. Don't you think that this solution is a little cumbersome solution for anybody? First, you take a picture and then it judges whether it is rotten or fresh. We can see it by the human eyes, isn't it? Why are you moving towards so much mechanical solution for everybody? Don't you feel that first the picture has to be taken, it will judge about a rotten vegetable or a fresh vegetable, and then it will give you a zero food
Fresh
recipe.
vegetable.
Let's say if I have a potato and of course I have know it that whether it is fresh or rotten. I can directly Google or I can ask ChatGPT, give me zero waste recipe for using a potato. So, I don't understand the main purpose of the research. I won't
Purpose of the
say
research
it's
is
a
mainly for
zero. It's only you want to say if for the youngsters, but I think we can teach all such things to youngsters rather than depending entirely on machine for checking whether the vegetable is rotten. That will become more cumbersome for me, isn't it? And again, even if it looks
yes.
good and it smells bad, that is rotten. That a picture cannot judge. So this is something which is my question. That this is a very cumbersome process that you
Okay.
are doing.
Yeah. So, yeah, madam. Actually, for freshness, we are feel with the human eye touch. You are absolutely correct. The thing is, any minute will be happen. For example, you take the onion, it will be give the some black dots. So that it's not recommended. It will give the some pop-up message like that. So that is the main focus on this. So it will
So
be
then you should be able to
helpful
predict
for
the
your
disease also, not only the rottenness,
yes, yes,
maybe the
yes,
disease of that particular
yes,
fruit.
yes.
If
This
you're
is
working on
yes.
then it is fine. But
Yeah,
otherwise,
disease
just
also it will
telling
be
rot.
predict. It is not recommended for the human. It will give the pop-up like this. That is the major motive here.
But there are a few doubts that I have really put it into your notice. I think you should
No problem. Yeah.
rethink about it.
Okay.
Right? The viability. Because look, when you are developing a sustainable solution, you should also talk about sustainable computations in that, right? So you are just doing unnecessary computations and resulting in CO2 emission for doing such a research. So you should think about on that parameter also. You'll be applying some machine learning or computer vision technique, and then you'll be coming up with certain accuracy for this particular project, isn't it? Now,
Yes.
every cycle of the computation that you are running, it also uh, takes some computational cost, isn't it? So, is the research worth the computational cost? Please just rethink on that lines also. This is my
Sure.
suggestion to you.
Yeah.
Right?
Okay.
Thank you,
Yeah.
Aruna. Thank you very
Thank
much.
you. Yeah.
Thank you, ma'am. Moving forward, I would like to call again Sir Osama Hamid to kindly present his paper titled A Threat Model Driven Architecture Framework for Motion Based Facial Authentication in Secure Web Systems. Do we have you here with us, sir? Do we have anyone else from the team present? Since there's no response, we will be concluding the session here. Uh, just give me a second. Yes, I think everyone is done. Thank you so much, everyone. I sincerely thank all the authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough, and we, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We'll be happy to have you in the 11th version in 2027 as well. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of WorldS4 2026. I also thank our session chair, Dr. Anuba Jain, for chairing this session. Uh, Thank you so much, ma'am, for joining
Thank you,
us.
Priyanshi. Thank you
There's
very
a
much. And all the best to all the presenters. All the best for their future research.
Thank you so
Thank
much,
you.
ma'am. As a small token of appreciation to you on behalf of Team World S4 and Global Knowledge Research Foundation and partners. Thank you for, everyone for your valuable presence. I kindly request everyone to turn on their cameras for a quick snapshot of the virtual conference before we end the session.
Ma'am, how many days it will be take for the publication?
Ma'am, it will take up to, sorry, it will take up to 7 to 8 months for the publication, and you'll get the certificates within 2 working days. Does that answer your question, ma'am?
Yes, ma'am. Got it.
All right. Can everyone please turn on their cameras? All right. I'll taking the snapshot now. 1, 2, 3. Thank you, everyone. Thank you for joining us. Have a great day. Bye-bye.
Bye.